Okay, now let's do part B. Okay, for part A, what I did was I tried to prove it, okay, blindly. Okay, so I just brute force it. 1, 2, 3, 4, check whether they're all true or not, or I can find any mistake. Okay, but what I usually do is I try to guess whether it is an inner product or not by using my imagination. Okay, I hope you can follow me. So for part B, let's do this. For priority, okay, I will check 1 first because this is quite easy to check. For 2, this is quite difficult to check, so I skip it first. Okay, this is the last thing that I will check. 3, it is very easy to check also, so I put this as my second priority, and this is my third priority. Okay, if these 3 things are satisfied, okay, then I will do this, okay, because this is the most difficult one. Okay, so so let's do this. Let's try. So my uv is just u1 v1 minus 2 u2 v2. This means, can I flip the u and v, right? What does it mean by vu? It means it becomes v1 u1 minus 2 v2 u2. But is it the same? uv, is it the same as vu? Yes, right? Because u1 v1, I can just flip this into v1 u1. This I can just flip this into v2 u2. And after flipping, it is just v comma u. So this is true. Okay, this is just in the rough paper. Okay, so in the test, you don't write in the solution just by ticking this. Okay, you need to show it. Okay, this is in rough paper. Okay, if all of these are true, then you need to write the proofs. Okay, if one of them is false, okay, meaning that it is not an inner product of V, you can just give a counter example. Okay, next, let's check whether 3 is correct or not. This 3 is also quite easy to check. It is basically, can I take out my k out? Okay, my k, meaning that can I factorize k out? So change this to ku, means ku1 to k2 v2, right? ku1 v1 minus 2 k2 ku1 v1 minus 2k u2 v2. So by taking the k out, okay, the inside will remain uv, right? So this is also true. How about for uu? Okay, this is also quite easy to check because uu means I change the v to u, so I will have u1 u1, which is u1 square, and u2 v2, but the v2 is just u2, so it is u1 square minus 2u2 square. Okay, is it true that it is always more than or equal to 1? Okay, I write it down. Is it true that u1 square minus 2u2 square is more than or equal to 0? No, right? This is very clear. Okay, so luckily we didn't go through one by one. I mean, prove it, trying to show that 1 is true, 2 is true, 3 is true, and so on. Okay, because actually this is not true. Okay, so we know that the problem should be here. Okay, so let's come up with a counter example. Okay, so 4b. Okay, so the counter example should be, we need to find, okay, let's use blue color. we need to find u1, u2, so that u1 square minus 2u2 square is less than 0. Okay, but this is quite easy. We can just pick u1 to be 1 and u2 to be 1. Okay, because 1 minus 2 is less than 0. Okay, so I can just pick u to be 1, 1. Okay, then my u will be 1 minus 2 times 1, which is minus 1, but this is less than 0. Okay, so we have u is less than 0. Okay, there is u, so that u is less than 0. Okay, hence it is not, okay, an inner product. Done. Okay, stop this. Before that, okay, for C and D, okay, I want you to practice yourself. Okay,